Hi, this is Russ Andersson. In this tutorial, I'm going to run through an export from SynthEyes to Fusion of a scene containing some meshes, a planar tracker, and also a bunch of lens distortion, and show how that comes out in Fusion. So we're going to start out with our shot here, which is just a little helicopter flyover that does have some lens distortion to it. And we're going to start out by auto tracking the shot and setting up a coordinate system using a couple of the trackers that are there on the field. Now we're going to go and tell SynthEyes that we want to calculate the distortion, and we're going to start doing a little tracker cleanup. And I'm just starting out sort of taking out some of the larger problems and then resolving, because early on the error of one thing affects the errors of the other thing. So we'll just work these down a little bit so that at this point, with any of the bad trackers eliminated, now they're just a relatively small number of larger errors in the tracking. So I'll just take those out. Let's just see, I don't know, take out the top 10, say, and now I'll just refine again. So at this point we have some reasonable error level, and our overall scene error curve is relatively flat. So we've got a reasonable solve to work from. So let's go over and we'll start working in 3D. And let's see if I can get this to fit. There we go. We'll just drop a teapot into our scene. I'm just control dragging that handle to be able to do a rotate. And let's also give ourselves a cylinder. And just for fun, we'll just stick that onto the teapot. And we should also smooth out the teapot there. Maybe we'll replace it a little bit. So now we've got a cylinder stuck onto a teapot, so that's what we'll be exporting as 3D objects. And now let's set up a planar. Since we already have the scene solved, we want to be sure to use the same lens for the 3D planar tracker. So I'm telling it that we want to use the computed lens value for this planar tracker. We're going to create it with a known field of view. We're just going to put it around this other field. Maybe we'll just adjust this a little bit. I'm just looking at this view over here. There's kind of another soccer field, it looks like. A smaller field in there. So we've got that on our planar tracker. And since we did this when the frame was at the current frame is at the end of the shot, we'll just reverse the tracking direction and let this track through the shot. Alrighty, so there we've got our planar. We've got two meshes. And we're just about ready to do the export. But before we do that, we need to run the lens workflow script here from the summary panel so that the lens distortion that SynthEyes calculated is set up in the image preprocessor, and it'll be used and exported by the Fusion export. So we're going to set up for a two-pass process where we're going to be delivering ultimately basically the original distorted shot is the final work. So you'll see how that comes out in Fusion in a minute. You'll see that it's adjusted our frame and it's adjusted the tracker positions and everything so that everything still locks up, but the frame has been adjusted so that it's linearized and so that it can be, have 3D images rendered that match up with it nicely, where the renders don't have to be distorted. So now we are ready to do our export. So we'll export to this Fusion 7 composite. There are a whole bunch of parameters. They are discussed in the manual. Basically, we're just using the defaults here. Most of them, I think, probably don't have to mess with very often. Now we're ready to move over into Fusion. And here's our Fusion version of this shot. So here's our final output. Let's put it up on the view there. So in the views, you see here are two different meshes. Here's our planar. And now let's walk through some of the things here. There's this point cloud that's producing all the little features there. And while we're at it, I think we'll turn off the make renderable part now for it. So that's useful for setting up other things, but we won't need it here. We've got our planar there. Here it is. And in Fusion, it is a plane object. So what we can do is go and create a loader. An image, we'll bring that and just drop that onto there. Whichever one that is. Yeah, so you need to drop that onto that scene input. So now we've got our sign stuck out onto that secondary field. And you can see if we scrub through this thing, everything is stuck into the scene. Some of the other things, we've got our teapot. Now the teapot mesh isn't in Fusion, so SynthEyes exports that as an OBJ mesh that is then read as a film box file in Fusion. So that's a film box node. We've got a cylinder. The cylinder does exist in Fusion, so that's exported just as using the Fusion built-in cylinder. And one of the options in that export is whether you want to do this or you want to just export everything. So that is the 3D part of this, really. There's a combiner that puts those all together, and then there's the render node that does the actual 3D rendering. Well, let's put that up over here. So that's the 3D render. But there's then a bunch of other stuff going on which has to do with the lens distortion, and that occurs at two places. at the one end, we're taking our initial footage and we're then taking the distortion out of it. So, well, that was the other view, but yeah, here's the undistorted version of it, and you see that there is an alpha channel, here that the image has been brought in from the sides, just like it was in SynthEyes. And that's being done by a custom distortion node that's been set up here. And it's actually using an image to drive this distortion process. So here's what that image looks like. And again, this was exported by SynthEyes. And rather than using a whole bunch of formulas to describe whatever kind of distortion is set up in SynthEyes, we're just using this image to describe the distortion. And this is really a great scheme that works for basically any kind of software that can do this kind of small trick, that you don't have to worry about everybody getting the right set of equations to describe the distortion. You just describe it all as an image, send the image around, and you're done, and everybody can do it pretty much the same way. So on the one end here, we've got a couple of nodes that are taking the initial image and undistorting it, and that's being used to feed into the rendering process here to produce our 3D rendered version. But then on the other side of the coin, there's another map. Put this up on the left display here, and this is the map that redistorts our 3D render. So, the way that this works is basically the red channel is the horizontal axis and the green channel is the vertical axis of what pixels should be used. So in this particular map, it never really quite reaches, needing these pixels at the end. So rather than getting to, a value of 1, it stops short of that because it's really getting this pixel down here to produce the redistorted version that fills the entire frame. So this is what that two-pass process is about. We start with the original images over here. We take the lens distortion out of them. We use that to do our compositing process, or to do the 3D rendering part of it. Everything matches up using those undistorted images. Then we render everything and redistort it back to an image that matches the original. So question is, why do we do this, and is this really what we want to be doing exactly? And the answer to that is no. What we really want to be doing is, rather than just having this process of using the image as the background for this render, we want to be actually compositing this rendered image over the original image and avoiding a whole bunch of distortion and redistortion to the original images over here. So let's show how we do that setup. So what we're going to do is add a merge node, and we're going to set that over here. Now it's set it up as the background, but actually we want that to be the foreground node. We're going to take our original image and we're going to connect it to be the background image of the merge node. So this original image is kind of bypassing all of the undistortion and redistortion stuff and then getting composited directly with the 3D stuff. Now there's something that we need to do here that's really, really important. If we look at the merge, everything is a nice image. Well, this node here, it still has all the background image in it. So what we want to do is disconnect this connection up here. And actually there's a a button you can hit to this guy somewhere also that tells it not to show the background image. But the easy thing to do is to just disconnect this here. And now the output of this render node is just the 3D things that you're adding. And you have this alpha channel that says where you need to add things. So that when you go and you do the composite, you're getting just the things that you're adding being stuck right over top of the original images, and you get your nice composited images. Now, the reason to do this also is that typically you're really going to be doing a lot more other stuff in between these two stages to match the render into the original footage better. And that might include, adjusting the colors, adjusting the levels of the shadows and the blacks, and adding noise to the images, and also softening out the alpha channel here. And in fact, I have a separate tutorial you can take a look at that shows one example way of how to soften out that alpha so that the final merge here comes out with less harsh edges around the edge. So the whole point of this ultimately is to make it look like your object is in the scene in the first place. So there's still a bit of work to be done to make that look as good as possible. And there's a whole bunch of discussion, a chapter called Realistic Compositing for 3D in the manual, and I urge you to take a look at that. So hopefully this has given you a look at how things show up in Fusion with an export from SynthEyes. Thanks and enjoy.